All right, moving on to our lesson about the 5-number summary and box plots. Here is an example of a box plot. You may know it as a box and whisker plot. But basically this is the minimum. This picture calls it the lower extreme, but the minimum. The lower quartile, or Q1, or the 25th percentile. Just a reminder that 25% of data will fall below that number. The median, or also known as the 50th percentile, so half of the data will fall below that number, half of it will fall above. Upper quartile, or Q3, or the 75th percentile, and then this is the upper extreme. This graph must not have any outliers on it, because if it had outliers on it, it would be graphed, and you would see probably a little star over here, something like that, if it had an outlier. Okay? So that hopefully will refresh your memory. So some vocabulary, and we've talked about most of this yesterday, so I'm just going to quickly review it. But the minimum is the smallest number. The Q1, or the lower quartile, or the 25th percentile. 25% of the data fall below that. The median is the 50th percentile. You guys can read through that. That is all new. So if you want to read and refresh your memory, go ahead and hit pause and go for it. Okay, some things you should know about box plots. A box plot is basically a graph of the 5-number summary, and the 5-number summary is made up of those 5 things that we just talked about above: the minimum, the Q1, the median, the Q3, and the max. Those 5 things make the 5-number summary. Okay? It is less detailed than a histogram or a stem plot. Okay, so it doesn't give you all the same pieces of information. You don't get to see any individual data points other than the min or the max. It is most useful when you're comparing more than one distribution. So that is when it is most useful. Here's another picture of a different box plot that goes up and down this time instead of left to right. So here's another picture. What I want you to notice is that the box part of it, of the box plot, is, if you subtract the 2 endpoints of that box plot, it is going to give you the IQR, or the interquartile range. And since this right here is the 75th percentile, and this is the 25th percentile, and you subtract it, here's 50% in here. So half of the data will fall within that box, basically. All right, here is some data about the prices of grapes in different vineyards in 3 different regions of the Finger Lakes. Okay, so you're going to find the 5-number summary and make a box plot of the Cayuga region by hand. We are only going to do Cayuga by hand, and then I'm going to have you go to your calculator and have you figure this out. Okay, so yesterday, yesterday we learned how to do the 5-number summary on our calculators. So actually, we're going to do that first. Okay, so we're going to find the 5-number summary using our calculator, but we're going to make our box plot by hand. Okay, so what I want you to do is I want you to go to your calculator. I'm going to refresh your memory. Okay, my Cayuga data is in list 2. So if I go to my calculator, I already have my data entered in there. My Cayuga data is in list 2. Just a reminder that if you need to clear your list out, so I'm going to go to list 2. If I wanted to clear this list out, I'm not going to, but if I wanted to, whoops, I would go up until the name of the list was highlighted, like, where is it? What's going on here? Like that. There we go. I would go up until the name of the list was highlighted, and then I would hit clear, not delete, but clear, and enter, and then it would allow me to enter that data into our list again. But again, my Cayuga data is in list 2. Okay, so I am going to go back to my main screen on my calculator. I'm going to go second quit. Okay, and then I'm going to hit the stat button, and I'm going to go over to calculate, and I want one variable statistics. So I'm going to hit enter here, or number 1. And then I need to tell my calculator where my data is. And remember, my Cayuga data was in list 2. So I'm going to go second, number 2 for list 2, and I'm going to hit enter. And there's a whole bunch of mumbo jumbo up here, which by the end of this trimester you will understand what all those numbers mean. It looks kind of scary, but if you scroll down, the 5-number summary should be there. So you can see that the minimum is 72, the Q1 is 78, the median is, all those numbers are listed there. Okay, scroll down and they are there. Okay, so I'm just going to copy them over here onto my notes so that I have them. All right, so my min is 72, my Q1 was 78, My median was 100. My Q3 was 122.5. My max was 135, okay? And then we will talk about outliers here in just a second. What I want to point out to you though is just a reminder that if you scroll down and that didn't show up on your calculator, that you might need to turn your diagnostics on. And to do that, you're going to go to catalog, which is second 0. So I would go second 0. And then go to the D's for diagnostic and scroll down until you see diagnostic on. Whoops, I went too far. And then hit enter and enter again until it's done. And then go back and recalculate your one variable statistics. Okay, is what you would need to do. So then I would go stat again, over to calculate, number 1, my data is in list 2, and enter. And then it should show up down there. Okay, so you might need to do that if it's not showing up for yourself. And once that's done, you shouldn't need to do it again. Okay, just a reminder of how to find outliers. Again, what you're going to do is you're going to take your IQR times 1.5. Okay, so first of all, you have to find your IQR. So your IQR is Q3 minus Q1. So that's 122.5 minus 78. And when I find my IQR then, I get 44.5. So what that means is that 50% of the data are within 44.5, whatever units you're talking about right here. Okay? Then I'm going to multiply that number times 1.5. And when I do that, I get 66.75. And then I'm going to take Q1 minus that number, and Q1 is 78. So 78 minus 66.75 gives me 11.25. And then I'm going to take Q3 plus that number, or 122.5 plus that number, which gives me 189.25. Okay, then you're going to look at your list, and right now I'm just focusing on the Cayuga region, just so you know that. I'm just focusing on Cayuga, and I'm going to look for numbers that are either smaller than 11.25 or bigger than 189.25. And you can see that I don't have any of those here, so I don't have any outliers. Okay, then what I want to do is I want to be able to make a box plot. And so again, every time you do one of these graphs that you needed to have a title to it. Okay, so I'm going to call this grape prices. And what's nice is I have 3 sets of data here, and I can make 3 box plots using one scale, and I'm going to put them right on top of each other. I'll show you what that'll look like in a minute. I'm going to put them right on top of each other. So to figure out how to scale my axes on this, it needs to be scaled evenly, but I really need to look at all 3 sets of data. Okay, and so when I look at all 3 sets of data, it looks like the smallest number is 52, and the biggest number might be 138, it looks like. So in all 3 sets of data. So what you're going to need to do is you're going to think about, what can I scale my axes by so that I can fit 52 in there and I can fit 138 in there, and I'm not going to be having too many intervals in there to make it hard to graph. So I think what I would do is I would probably start at 50 and then go up by 25. So I can start at 50, 75, 100, 125, and 150. And by the way, this is grape prices in dollars. Okay? So then what you're going to do is you're going to just graph this. So there are no outliers, so I don't need to make any little handy-dandy little stars. So the smallest number, and I'm just worrying about Cayuga here. Okay, so the smallest number is 72, which would go right about there. My Q1, and I'm going to actually write this. Min is 72. My Q1 is 78. My median is 100. My Q3 is 122.5. So here's my box part of it. And again, 50% of all the data pieces for Cayuga will lie within that box if you were to plot them individually. And then my max would be 135. And again, no outliers, so my whisker is going to go all the way to my max. Now, if I were to do the other two regions and find the 5-number summary for all of them, I would not need to redo this scale. Okay, I would not need to redo it. If you flip your notes over to the back side, what I have is I have those graphs on your notes all listed on there in one graph like that. So I've got Cayuga and Keuka and Seneca, and they're all labeled. And I didn't take the heart or the space to label all of these, but you really should label that this is your min, this is Q1 on all of those, okay? I didn't take this space on my whiteboard to do that, but you should do that, okay? So that's what you would do. You can see how you have one scale on the top, and you can just do it like that, okay? We are going to go back, though, to our calculator because I want to show you how to find the 5-number summary a different way and also how to graph all 3 of these on the same scale. Okay, so I'm going to go back to my calculator, and I'm going to hit the Stat button and Edit again just so that you can see this. So I have the Seneca region in List 1 and the Cayuga region in List, Cayuga region in List 2 and the Keuka region in List 3. Okay, so get your data in. You can hit pause and get your data in, and then we'll be back here. Okay, so once you get your data in, I want you to hit quit. Okay, and what we're going to do is I'm just going to clear this out just to make it easier. Anytime you want to graph statistical data, make a graph of it, you're going to need to go to StatPlot. And StatPlot is in second y equals. Okay, and number 1 just means it's the first graph that you'll see on the screen. Plot 2 is the second graph you'll see on the screen. Plot 3 is the third graph you'll see on the screen. You can graph up to 3 graphs at one time. What I want you to notice right now is that plot 1 says off. I am not going to see a graph for plot 1 right now because it says off. Plot 2 says off, plot 3 says off. I am not going to be able to see a graph for them because they are turned off. Okay? So I'm going to go one at a time and get each of the 3 regions to show up. So I'm going to first hit number 1. And the first thing I have to do is turn it on so that it shows up. So scroll over to on and hit enter. Okay, then you're going to down arrow to the graph selection piece, and you're going to scroll over and keep using your right arrow. At this point, you can't use your down arrow. Use your right arrow. I would suggest using this type of box plot because it's going to show you the outliers. The other box plot over here does not show you the outliers. Okay, so we're going to use this one that shows you the outliers and hit enter. Then for my first plot, my data is in list 1. Okay, my first plot, my data is in list 1. And then the frequency, you don't need to worry about. And then this just shows you what shape you want your outliers to be, so don't worry about that. Okay, so that's that. Okay, so now I'm going to see a graph for plot 1 because it's turned off. On, I mean, it's going to be a box plot that shows the outliers, and my data is in list 1. Okay, then I'm going to go back to stat plot. I'm going to go down to not plot number 2. I'm going to go in here. I'm going to turn it on so that I can see it. I'm going to go again, select another box plot, and hit enter. This time, though, my data is in list 2. So I need to go down here and tell my calculator that my data is in list 2. So I'm going to go second 2. Okay, and again, it just selects the type of mark you want for your outlier, and you're good. Then I'm going to go back to stat plot, second y equals, and I'm going to go into plot number 3, and I am going to turn it on so that I can see the graph. And again, I'm going to go and I am going to select the box plot that shows me the outliers. This time my data is not in list 1, it's in list 3. So I need to tell my calculator that, so that's second 3. Got my outliers set, and you're there. So now you've got all your graphs turned on, you've told your calculator where all the information is, and now you just need to graph it. And so what you're going to do is you're going to hit zoom 9. And if you hit zoom 9, all 3 box plots will show up at one point. Some of you might have some data in your y equals. If you have data in y equals, I would go in and clear that out because it's probably, you might be seeing a line or something across there. Okay, now if I hit the trace key right here, Oops, sorry, wrong button. Sorry, if I hit the trace key, what I want you to notice is down at the bottom down here, it gives you the minimum point for that plot. You can see you don't have any outliers because there's not any dots. And if you right arrow over, Q1 shows up. If you right arrow over, the median shows up. And so if you just want to graph these instead of doing the one variable statistics, this will also give you your 5-number summary. Then I can scroll down to get to the next plot, right arrow over, all of that good stuff. Okay, scroll down. There's your Q1. Notice, yeah, there's your Q1. And if you scroll over, there's your minimum, and you can also see that it's an outlier because the whisker is not connected to it. Okay. So I didn't do these in the same order on my calculator as I did here, but you get an idea. These are the 3 graphs similar to what you see on your calculator. I just did them in a different order. And now we're going to just answer some quick questions about them. Okay, so which lake region produces the most expensive grape? The most expensive. Not the most expensive in general, but the most expensive grape. And the most expensive grape would be seen right here, which is in the Seneca region. Which lake produces the cheapest grape? The cheapest, and that's it, which is also happens to be in Seneca. In which regions are the grapes generally more expensive? And like right here, this is the 50% line. So 50% of all the grapes in this region are above that number. 75% of all the grapes in that region are above that number. Pretty easy to see that Cayuga has the most expensive grapes. Okay, then write a few sentences describing and comparing these distributions. Again, I want to remind you that when I ask you to do this, the 4 keywords are center, shape, spread, and any unusual characteristics, or if you see any outliers in there, those would be key things to point out. Okay, so this is what I would say. If I were to describe shape, this is what I would say. I would say all are pretty symmetric. All of them are pretty symmetric. The Seneca region may be just slightly skewed left. Just maybe. That's not even real clear, so yeah. The grapes in the Cayuga region have the smallest spread, so Cayuga has the smallest spread. And the other 2 regions are pretty similarly spread to each other. So Cayuga has the smallest spread, or the least variability is going to be another way to say that you'll learn in a little while. Cayuga has the highest priced grapes. So it definitely has the most expensive grapes. And I'm going to say that, I know that, because it has both the highest Q1 and the highest median. Okay, and those give us some key information about that. And then the other thing I would say is that Cayuga, and by the way, I should probably go back. Cayuga has the most expensive grapes, and I'm going to say this. The other 2 are similar to each other. Other 2 are cheaper and similar to each other. All right, and then I need to address that outlier in there. So Cayuga has 1 vineyard with unusually cheap grapes. I don't know what it is. I don't know which vineyard it is. I don't know how cheap the grapes are exactly, but I know that they are unusually cheap grapes, and I know that because I can see it as an outlier. Okay, so that's what I would expect you to write there. And then, oops, those are, okay, these are calculator instructions, you guys, so if you are having trouble with your calculator, you can hit pause and read these, okay? Then draw box plots that have different shapes. So a box plot that is symmetrical will look like this. Really, you guys, the most important part to attend to on this is the box part of it. Don't worry so much about the whiskers. Worry about the box part of it and where that line falls. Skewed left would look something like this. That would mean it would trail off to the left and it's stacked to the right. So that would mean that this median line is here and you have a whole bunch of data to the left compared to the right. Okay, skewed right obviously will be the opposite. Okay, and then outliers can show up one of two ways. You can either have something where it has a really long whisker like that. Okay, so some people draw them like that, or some people show them with the little dots like that. And that would show that it has outliers as well. Okay, so hopefully that brushes you up on STEM or box plots.